So we're going to continue our discussion of law of sines in this video, the second video of law of sines, and we're going to talk about something which we'll call the ambiguous case. So let's go back to, in the first video I talked about SSS, SAS, all of those. So far with law of sines, we can use this when we're given ASA or AAS. If you look at the previous examples, you'll notice that in this one we have ASA, if we're kind of going around the other way. And then for this one, we end up with AAS. So law of sines works really well with both of those. If you're given two angles and then a side, you can find it that way. However, we can also use this with this one, SSA, or sometimes you'll write this as ASS. And that's the way to remember that this is the bad one. There's always issues whenever you have ASS. And so this is going to give us issues. So we're going to do three different examples for SSA to show the different issues. Essentially, you could have either, could end up with three different situations. We could end up with one solution. We could end up with two solutions. Or we could end up with no solutions. And that's because if you're given a side-side angle, so for example, let's say I have this side is given, and then let's say this side is given. So we have something like, let's do 22, call this 42 degrees, and then this one is 12. So notice I could just go ahead and draw that up there, and that would be my triangle. So that works out really well. Or potentially what might happen is I have 12. The 22 actually goes like that. And so this would still work, except the triangle would end up looking like this. So that's why we say that this is ambiguous. Because there's actually two different triangles we could potentially create, or we might not be able to create a triangle at all. So let's go ahead and take a look at each of these situations. And the really big takeaway is whenever you're given SSA, it's important just to know to double check your answer. So we'll start off with, we're going to find all missing sides and angles. And I'm just going to go ahead and we'll do three parts. So part one is going to be this triangle that we just were talking about. We're going to call angle A 42 degrees. Side A is going to be 22. Side B will be 12. And let's call this, let's do some units again. So we'll do inches. Now my first step is going to be to label the missing sides. So we'll go with our generic labeling system. CB, and then this is lowercase b. And now we need to solve. Unfortunately, we can't use that the sum of all angles in a triangle is 180. So we're actually going to go straight into law of sines and figure out what we can do. So notice I am given an angle and a corresponding side. So that's the ratio I'm going to be using. And let's just say I want to solve for b to start off with, for capital B, the angle. I'm going to actually use the reciprocal version of what we've been using so that my angle is already in the numerator. So I'm going to say sine of b. Oh, you know what? I can't actually solve for b because I don't have side b. So we're actually going to solve for c to start off with. So I'm going to do sine of capital C over side C, 12. Notice I wouldn't have been able to do that with b because I don't have lowercase b. This has to equal the ratio sine of 42 degrees over 22. So if we're solving this, I'll first multiply the 12. So I'll end up with sine of C. And we'll have sine of 42 degrees over 22 times 12. And then I'm taking sine inverse of both sides. So I worked all this out beforehand. You can do some intermediate steps. You could write down what that equals in the parentheses, but I'm just going to go straight to the final answer, which is that C is approximately equal to one sec, 21.4 degrees. Okay. Clearly this triangle is not drawn to scale, so that's okay, but just something to keep in mind. So I end up that C is about 21.4 degrees. Now, because this is the ambiguous case, and we just did sine inverse, we could say that C is approximately the supplement of this angle. Just back when we were doing sine inverse, we said if you have sine inverse of something, it could be here, or it could be this angle. And so technically we should also figure out what this is. So C would be approximately 158.6 degrees. However, this doesn't work in this case, because if I add up the 158.6 plus the angle that was given to me, which was A, which was 42, this is already going to be greater than 180 degrees. So it doesn't work because the fact of the matter is the angles in a triangle have to add up to 180 degrees, and that doesn't work. So in this case, there's no ambiguity. We know that that angle is 21.4 degrees. Now we can solve for B. B is going to be approximately 116.6 degrees. I used the sum equaling 180, so 180 minus 21.4 minus 42 gave me 116.6. And then finally, we can now solve for side length B. So let's go ahead and do that. B over sine of 116.6. I'm not using the rounded version when I actually do this on the calculator. Equals A over sine of the angle 42 degrees. And so if you do all that, you should end up with B approximately equal to, so multiplying both sides by the sine of 116, you end up with B is approximately 29.4 inches. So there's our final answer. The missing pieces are angle C, angle B, and then side B as well. So that was the situation where there was one solution. Let's go ahead and do another one, and let's look at this one's going to end up with two solutions. So this one's going to be ambiguous. Okay, so side A is going to be 12, let's go meters, change it up a little bit. Angle A is going to be 20.5 degrees. Angle C is unknown. Side C is unknown. And then side B, is going to be 31 meters. And this will just be angle B. It'll be unknown as well. Okay, so let's do a quick check. This is in fact SSA or ASS. The next step is to figure out if we can find any angles. We cannot, so we're going to go straight to solving for B. Starting to get a little bit lazy. I don't like to put the parentheses around it. It's just an extra step, but just know that there are sort of implied parentheses there. Okay, so if we solve this, we're going to end up with B equals sine inverse of sine 20.5 degrees over 12 times 31. And so this gives me that B is approximately equal to 64.8 degrees. Great. Now we do need to double check because this was sine inverse, b could also equal 115.2 degrees. The way I found that is I also did 180 minus 64.8. And this time it will work, because if I add 115.2 plus my original angle A, this is still less than 180 degrees. So this is a situation where the triangle could actually be one of two things. It could actually be oops, I just drew it the exact same way. So we might have this angle at 20.5. This is 31, and instead of the 12 coming down this way, it might be that we actually have something like this. So there's actually two different options for this triangle. Okay, so let's go through the process now. Using this, the sum has to equal 180. We end up with C is approximately 94.7 degrees. So in this case, I did 180 minus 20.5 degrees, and then minus the 64.8 degrees. And then over on this side, we would end up with C equaling approximately 44.3 degrees. Once again, I'm using that the sum of all the angles have to equal 180, except I'm using this alternate B value. Okay, so we have B and C in each situation. And then finally, we're going to use the law of sines to calculate side length C. So I'll do C over sine of 94.7 equals, I'll go back to A, side A over sine of angle A. And so we get that side length for this first scenario is approximately 34.1 meters. And then for the second scenario, we end up with 23.9 meters. Okay, so there's two solutions in this case. We have one solution here, and then we have another solution over on this side. It's kind of like when you take a square root of both sides, you get a plus or minus. There's two options. Same thing here. There's technically two triangles we could create. And then for the last example, let's take a look at a situation with no solution. So in this case, I'm going to say that side, oh, this was part C. Sorry, this is part C. Side A equals 15 centimeters, side B equals 25 centimeters, and then angle A equals 85 degrees. So if we're going to solve this, we'd probably want to solve for, first we'd probably want to draw a diagram. So even though we know that this will be no solution, let's just go ahead and draw a triangle. So we're going to solve for angle B to start off with. So that means that sine of B over 25 has to equal sine of 85 degrees over 15. If you do this, you end up with sine B is approximately equal to 1.66. And if you try to do sine inverse of 1.66, you end up with no solution. That's because 1.66 is outside the range of sine. It's not in the domain of sine inverse. And so in this case, we say that there is no triangle or no solution. All right, so that covers the law of sines. I know this was a pretty extensive couple of videos, but I did want to give you a couple of different examples of that ambiguous case. In the next videos, we'll cover law of